Great. So my name is Robert Starmer. I run a little technology consultancy. We help people get efficiency out of cloud, and it's kind of the topic of the day. We've talked about all kinds of topics in the past. As Lisa said, we talk a lot about containers. We've done a lot of OpenStack work. There was somewhere, I think on Twitter or something, somebody the other day said, "Oh, what was the earliest conference you went to?" And there was some Cactus. There was a lot of like Grizzly and Folsom. And I realized I actually went to the Behar conference. I didn't realize I'd gone to the Behar conference because at the time it was just this thing. Oh yeah, OpenStack. These guys from NASA and Rackspace got together and did this thing. So I've been around for a little while in that space. As Lisa said, I'm a certified OpenStack admin. Actually, that is going to expire because now I helped with the test the last time around, so I don't get to keep that one. But I also just got a Google certification because, hey, why not? Google, right? But the thing I want to talk about is efficiency. And when we start thinking about containerization as a process for efficiency, it really changes how we think about application development, right? And if you're a developer and you start in on this from the sort of the developer perspective, you find that a couple of containers are easy, right? Throw them on your laptop, you work with them there, the pieces fit together really well. It's really a lot of fun to work with these tools. It really simplifies a lot of things. And from an operations perspective, which is really what I focus on, simple too, because I don't have to worry about it. You're doing it on your laptop. I don't have any problems. But as soon as we get to larger deployments, the problems start to creep in, right? So even as an end user, we want to find tools that make it easier to manage containers across potentially multiple systems. It's one of the reasons that everybody wants to talk about Kubernetes these days, because that's the tool set that simplifies the process of managing containers across multiple systems, managing container lifecycle and the processes around that. So from a development perspective, we see this shift towards using this new layer of middleware called Kubernetes in our containerized processes. The thing is that that's not the only part of the story. As we start to continue to expand our reach, as we start to operate potentially multiple Kubernetes environments, or even a single environment but with multiple namespaces to provide segregation and resource management, we see even larger problems. How do we keep track of what resources are being used? How effectively are they being used? How do I deal with multiple clusters? Are they all being used equivalently? Is there one cluster that's getting all the work and everybody else is just sort of sitting idle? If I'm building this in my own data centers, maybe I don't care so much. Actually, I don't agree with that, but you could say maybe I don't care. But a lot of people are actually using Kubernetes on top of a public cloud. So suddenly, you really have to start caring because resources that aren't being used and aren't being used efficiently actually do cost. Right? And you could say, look, a VM, $50 a month, right? And you suddenly start realizing, it's not a VM, it's 100 VMs, dealing with thousands of containers. Where's the efficiency modeling? How can I understand what's really going on within those environments? And that ends the really cool part of the presentation. You can thank John for the awesome images. Now we can get into text. But really, I think the cloud is part of the problem. And I jokingly called this, how do you save money on cloud? That's easy, right? Get rid of the cloud. Then you don't have to spend any money on it. But that's not going to happen, right? We know that cloud is here to stay. So really the question is, how can we make cloud more efficient? 20 years ago, 25 years ago, I was a sysadmin. And every time I started looking at what people were doing on the systems, I realized that it didn't matter if you added capacity. Capacity didn't necessarily solve the problem. It might address an issue if you don't have any capacity, but as soon as you provide capacity to engineers, who here's an engineer, by the way? Most of you? Yeah. So what happens if somebody says, we've just mounted another 800 terabytes of storage on EMC? Who doesn't kind of go and say, oh, really? Create a volume over there, grab a couple. I'm going to need them tomorrow, I'm sure, right? That's classic. Why? Because we're worried that there isn't capacity when we need it. Because we've run into that situation. I've got a project. I need to do something now. I need capacity. I can't find it. Well, the cloud problem, the cloud value is that we've given you the ability to find that capacity. From an operations perspective, I can step out of the way. The developers can get whatever they need whenever they need it, right? And yet the old mindset of, I think tomorrow I was going to spin up another system. I need some more. I'll just grab it now. Grab it now to make sure that it doesn't run out tomorrow. Anybody do that? Anybody leave the room and leave the lights on? Yeah, come on, we all do this, right? We want to be good, we want to be efficient, we want to turn the lights off, and we kind of tend to forget about that, right? But the part of the problem is that we don't see it. The lights are on. Well, that means that we can see what we're doing, but we don't think about the fact that by leaving the lights on, we're actually costing money. And part of the problem is the low cost of some of these services. $70 a month, who can't pay $70 a month in a company? Come on, everybody can handle $70 a month. It's that, not $70 a month, it's the fact that it's $70 a month and you got 50 engineers. Right? So suddenly this becomes significant money every month for that one VM that you're just like, I'll just leave it there, I don't have to worry about it, right? And it's the dynamic potential of the web, or of web scale applications, and the need to support that. Hey, I might need to be able to scale up and down, so can I test that? Right? Well, let me scale it up. Great, it works. And I go off and do the next thing that I was going to try to do. What did I forget to do? Let me turn the lights off. Right? So this is really a problem, and it's something that I think gets even worse when we start adding in Kubernetes. Now, I'm a big fan of cloud-native applications, cloud-native development, DevOps, and even the Kubernetes space. I'm not trying to say any of this stuff is bad. It's just that we have to become aware. Right? There's a lack of awareness for a lot of this. Kubernetes is great because from an application developer perspective, I can scale on demand even potentially more effectively and more efficiently because many of the operational tasks that I need to do are taken care of for me. Right? I have deployments that can handle not just scale up and scale down, but rolling upgrades, rolling downgrades. If I need to think about how am I operating my application, I'm the DevOps guy, right? So I need to be able to do development and ops. Well, this tool really makes my life a lot easier. But one of the biggest gaps in all of this is that we suddenly lose awareness of the underlying infrastructure. Who's deployed Kubernetes? Anybody deployed it or just used it? Anybody used it? Do you guys know what Kubernetes is? Containers, anyone? Anyone? Right, so if you've ever deployed a Kubernetes environment, often what you're doing is specifying two pieces of the puzzle. One is, what does your control plane look like? How big does it need to be? And what does your compute resource, what do the worker nodes need to look like? How big do they need to be? Right? So if you're actually starting at that level, if you as the developer are also deploying the Kubernetes environment, you do have some visibility into the infrastructure. But many developers are not deploying their own Kubernetes environments. They're either getting an entire environment handed to them, which is fairly common, or they're sharing part of an environment as a part of their team Kubernetes environment. So they don't see what the resources are, so they start using it in much the way engineers tend to use things. Well, let me go deploy something and I'll leave it there, and then maybe I'll upgrade it and downgrade it. That's actually great. That is part of the concept behind the Kubernetes lifecycle. But what also happens is somebody says, well, okay, I'm done, and I'm going to be a good citizen. I'm going to clean up my stuff, turn off all the containers that I was running on that system. What did I not turn off? Anybody? Yes? Yeah, you forgot to turn off the Kubernetes system, right? And part of that is, well, there's now a gap, potentially. If the developers aren't developing and deploying even the management layer, they're not in charge of that Kubernetes system. So why would they turn it off? It's not their job, right? But it's still resources that are being consumed. Now, some of the cloud providers and even some of the companies that are providing Kubernetes deployment, automation, and management are taking that into account. They're starting to look at, hey, if there's really nothing running on these environments, I can start turning nodes off. And in most of the public clouds, I think actually all the key public clouds, well, at least what I think of as the top four, I keep adding IBM into one of the top four. I mean, they actually have a very nice Kubernetes deployment. But all of those companies actually provide you a master for your Kubernetes environment that you don't have to run. So you don't own those resources, you don't have to manage those resources, they don't cost you anything because they're provided as containers on demand as well. Right? So it's kind of a nice way of doing it, but you still have to think about your own resources. And many of those platforms now also support some form of auto scale on the underlying resources themselves. So it's great. I start to get some real value out of this, and I don't have to worry as much about the underlying infrastructure. And again, this is also true for, I believe the Rancher guys have some tools in this space, Nirmata. There's a half dozen companies that are sort of working on this. And really what we're trying to do is address the user interaction problem, right? This lack of visibility of the infrastructure, how it scales, when it scales, if I'm actually using it or underutilizing it. And I think it's the gap that still exists is not the use part so much, that we're starting to see, like I said, the cloud providers and management tools on top of getting a Kubernetes system deployed are starting to manage the scale of my environment. How many nodes do I have? But I still have to pick a node size. How many CPUs do you want in your node? How much memory do you want to add to that node? Do you want one type? Do you want multiple types? What are you deploying on top of this cluster? Right? So again, from a engineering mindset. Well, let's see, I'm going to deploy some database, and that usually needs a lot of memory. I've got some machine learning nodes. They need actually CPU or even TPU instances or GPUs. I need, storage, so I'm going to get some storage capable nodes. And now I have one machine that has TPU or GPU, has half a terabyte of memory and 64 cores. Well, let's see. Okay, I'll use that for my worker node, and I need 15 worker nodes. Anybody have an idea of what that might cost on Amazon? Like $10 an hour? I mean, that's significant versus 7 cents a CPU hour, right? There's a big delta there in terms of that kind of cost. And that's just part of it. It's not that we're not trying to do the right thing. We know we're going to need these resources, and so we want to be able to turn them on demand, but we're not really controlling the resources effectively. And we have no tools, really, for managing that. Has anybody actually set up monitoring on a Kubernetes? Well, most of you haven't even set up a Kubernetes environment, so you wouldn't have set up monitoring on it. But you're not thinking about monitoring it because why? It's not my infrastructure. That's infrastructure under the system that we have to look at, right? So access to the resources, utilization, it's, I think, a big problem that most people forget. They don't see it, right? So all I really want to try to do is give you guys a little bit of awareness. Classic quote, great power carries with it great responsibility, and we forget the responsibility and forget about the anxiety because we don't have the response. No, wait, that's not what it says, right? Great power carries with it great responsibility, and great responsibility entails a large amount of anxiety if you're actually thinking about what your responsibility means, right? Am I being fiduciarily responsible to my company when I'm managing cloud resources, right? Classic, 5 years ago, 6 years ago, I remember the story was always, yeah, the CFO was at the annual board meeting, and the CEO said, well, what's going on with our Amazon usage? The CIO says, we're not using Amazon. What are you talking about? The CFO says, I beg to differ because I have a bill every quarter for $250,000 worth of spend. Where is this coming from? Right? Developers saying, well, we need to do this, and we're just going to go do it. Right? So we need to start thinking about the responsibility for that infrastructure as a part of our development. So how do we start to understand what's going on? This is sort of like the next big question. Last good image, by the way. That's it. It's like, what's the wish list of tools that we have? We want to be able to understand how we can eliminate waste, right? Can we manage our resources more effectively to handle small-scale, large-scale needs? Can our development teams be more efficient in how they use resources, especially cloud-based resources? These are all tools that we would like to have access to. Can we track idle use versus busy use? This is a tricky one. Has anybody ever actually looked at metrics of a system that's in stasis? Anybody? Yeah, and what do you see?
Nothing.
Do you really see nothing?
Well, there's a little bit of disk.
Uh-huh. Okay.
CPU's always got some kind of heartbeat going on.
Yeah.
And there might be a tiny little bit of network traffic.
Yeah, except that now we're talking about systems like Kubernetes that have, distributed communications protocols. They're not doing anything, but they want to make sure that they're consistent all the time. So they're always sending some traffic. So it's more than just the heartbeats anymore. It's more than just NTP pinging off to the NTP server every once in a while to make sure that the time's in sync, right? So the question is, how can we actually look at a system and say, oh yeah, no, that is truly idle. It might be running my environment. I've got 400 containers deployed, but is it idle, right? There currently aren't really good tools for this because most of the tools are doing basic analytics. Is there utilization or not, right? So it's a gap. It's something that I think we would really like to do. Can we determine if we're right-sized or over-provisioned? This is tricky, right? Because just saying, oh, well, look, I'm running the system. If I give it all the memory and all the CPU and all the disk in the world, it uses this much, so I can just make those my limits. But if I actually do constrict things to those sorts of limits, that doesn't always mean that the system continues to function properly. Because it might have been using that memory in a cache mode because it thought it had so much. When it suddenly doesn't have access to all that extra memory available to it or potentially available to it, it suddenly doesn't work as well. Right? So even right-sizing is something that probably needs machine learning input, because that's the only way we're going to be able to teach the system what is really idle or what is really not used. And then we can even look at how we might optimize or further optimize our right-sized environment. So this is sort of what we want to try to accomplish. And I think there are a number of tools that we could use to do this. There are some really great metrics management tools. We can start tying into the DevOps lifecycle to help us with this too, right? Let's not think this is a one-shot deal. Let's start thinking about what DevOps means. And the reason I start getting into this instead of just pure efficiency is because this is the development model that we have, Right? This is the one that everybody says is the best way to go about building your applications. Right? Again, in the process, when I go through a build process, if I've automated all this, it's great, because now I can actually start stepping out of the way of manually building infrastructure. Right? But it is still linear. Right? You start at the left and you end up at the right. Acyclic directed graphs, or directed acyclic graphs? Yeah. Right? So it's always single direction. I spent a lot of time working on Puppet and Ansible automation tools. They're great. Right? What do people write when they write Puppet or Ansible code? They write the control code and the logic to create something. Great. Well, what's the other half of that? Yeah, who writes that? Almost nobody. Why? Because on top of the fact that I have to get my job done, I've got work to do, I don't have a whole lot of time to keep messing with this, but the automation works. It gets me through that build process. My test's complete. Hey, that's great. You know, my delivery happens. Okay, I can just delete all the other stuff. That's the easy delete, right? But if we actually have systems that want to stay on all the time and are going to be right-sized by these sorts of environments, by these systems, we have to start thinking about, this is one view of the world, but we have to add to it. At the cloud camp that Lisa mentioned last week was a really interesting small group, because I think it only got announced sort of almost the day before. But a lot of what was being talked about was the shift in operations. Right? So when we start thinking about, again, the developers don't necessarily even have visibility into what's needed in the infrastructure, but the operations guys do. But many of the operations folks are what I consider old school operations, and that's not a bad thing. That's just the way it is today. Right? What is that? It's configuration management, it's compliance, it's security management, hopefully, and it's lifecycle management. Right? These are core things, and most of the focus is on the infrastructure. Maybe now we're actually starting to creep up into the virtual machine management, or even into the Kubernetes layer, container management layer. Right? But it's that basic sort of set of services. And I think what we're starting to see is that operations needs, or is becoming, well, I think it actually needs to become more data-driven. Right? So we need data access, we need alert and event management. If we can start thinking about operations not as an alert comes in and I have to go through my run book, but instead I can automate those processes, which is why I need to automate the undo as well as the do. Right? I can actually get better operations out of my environment. Compliance, validation of audit support, we still need that. It's not going to go away. But our environment is much more dynamic. People used to think of audits as, well, like, show me the configs that you have that have been static for the last 30 days. So I just need a 30-day snapshot of my audit logs. That's not adequate anymore if I'm turning things on and off every 5 minutes. Right? So now I need to actually keep track of a lot more information as well. Right? So suddenly the operations has to become automated. Right? Automated automation is what I keep saying. You know, it's not only do I have to look at the automation, but I need to figure out how I automate that automation. And if you look at the DevOps cycle, that's already started to do that. Right? I've already started to automate my automation. I have continuous integration, continuous delivery, continuous deployment models. Right? Each one of those stages, each one of those pipeline elements is another set of automation tasks that have to happen. Right? Now I've luckily got ways of stopping things if they break, but you know, I still think that there's are shifts that are happening, and we're starting to see them. In terms of this sort of deployment model, there are things like Helm as a tool. Now, since most of you haven't messed around with Kubernetes or haven't had a chance to work with Kubernetes, you may not know that much about Helm. But Helm is a really nice tool for deploying an application. And because Kubernetes has built into it some really nice management, lifecycle management components, like deployments, which actually can scale up and scale down and add and remove resources, Helm has a reasonable way of cleaning itself up. So you can do Helm create and you can do Helm destroy, and that works really well. Unless you were a little lazy and you said, well, let's see, I need to have a container deployed. That container needs a configuration file. And so in the Kubernetes world, there's this concept of a manifest, which is a document that describes potentially how containers are deployed or how configuration files are written into the system and connected into your containers. Well, if you lump all that into one file, which you can do, because it's a YAML document, and YAML documents can be separated internally, Helm sees that as one document, and when it does a delete, it only undoes what the main part of that document was trying to do. So I might deploy a pod, which is the base sort of resource in Kubernetes, and at the same time deploy a configuration file. And when I tell Helm to delete that, it just deletes the pod, leaves the configuration file behind. Right? So even Helm has sort of this fairly linear thinking model built into it. And part of that comes from the fact that Helm was designed as an installation tool, a package management tool, a simplification of saying, oh, I need to have a database and an application service and maybe a front-end web proxy or scale engine built together to build my application. And it does a really good job of that. But when we start thinking about the operations of that environment, what happens if my database gets corrupted? The only thing Helm can do is delete it. Right? It doesn't have any logic for managing the operations of an environment. So somebody came up with this idea of saying, well, there is operations still required even in this fancy web scale cloud native environment that is built by Kubernetes. So we can start automating more than just the create and uncreate process. We can start thinking about the operational processes. What happens if something breaks? Can I use the operator to help me fix that failure? Right? And that's a really powerful tool. And I think it goes almost far enough. There's effectively one piece of this puzzle which takes us back to this concept of efficiency, which is missing. And that is that we actually really want to start thinking about the events that are happening, and we want to be able to analyze those events and tie in not just the start-stop operations and potentially the scale event information that we are probably collecting. If we're really building a scale-out app, we need to know when to scale up and when to scale down, and Kubernetes helps us with some built-in control for that. But I think we can take it one step further, and we can actually start thinking about what additional analytics do we want to include in the description of our applications. Right? So do I want to, for example, tell my monitoring system to capture additional data about my application, something that's specific to the application itself, not only the underlying infrastructure? Can I actually incorporate actual logic models as a part of my deployment? Prometheus, for example, is a tool within the Kubernetes community, well, the Cloud Native Foundation community, to help manage metrics and analytics and alerts. It's one of the tools, not the only tool for doing that within the Kubernetes space, but it's a fairly powerful one. I could include Prometheus-based models as a part of my deployment and get better visibility into my systems. Right? And I think that's one of those things that's really going to change how these environments work. Now, I think, again, cool picture. Okay, that was the last cool picture, sorry. Maybe there's one more. So, as I said, I'm a consultant, and one of the things I keep running into are some of these problems that people see. Right? This whole lack of visibility into the efficiency of our environments, to a certain extent, even the lack of visibility of what's going on in our environments. I've talked to a lot of companies who say, yeah, we're spending $10,000 on Amazon, $50,000 a month on Amazon. We really don't know what it's doing. We know our engineers are happy. They're getting their work done. So in general, we're good with it. But is that really efficient? Again, is that fiduciarily responsible to the company? How do we figure that out? Well, we've started to develop a tool. This will become open source within about the next month once it's a little bit more stable, because we don't want to put crap out there. We are looking at how can we optimize cloud ROI. And to me, part of that comes down to not just building the monitoring tools, but actually seeing the data. Right? Like I said, in order to really understand if a system is idle, we probably have to have machine learning as a back end to that. So we have to have machine learning capability here. Machine learning capability is two things. One is it's data collection and data analytics. Great. But you still have to teach the machine. Right? So you're going to have to go through, somebody's going to have to go through and look at the state of these application environments that are being deployed and say, yes, this is a segment of time where the system is truly idle. So start thinking of this kind of behavior as idle. Whereas this kind of time within the system is actually not idle. This is active testing. This is active production. Right? So we're looking at implementing that. We don't have that component implemented yet. Right now, it's more a visual view. Hey, this is what's going on in your system, and you can scroll back and forward and see what's going on. Right? So it's a first-level dashboard for this. The second part of this, of course, is really sort of understanding what we're trying to accomplish with the tool, but it's providing visibility. It's providing reports. Right? The idea is that you can get a daily report. Initially, it'll be a daily report of all your systems. Right? That's what we're generating today. In a next version, with some simple filtering, we can say, well, look, here are things that have triggered an alert. Right? We're seeing less than 10% CPU utilization. May or may not be idle, but we think that's probably not really great utilization of this system. So if nothing else, I'd like to alert the operators to say, maybe check this environment out, talk to the user of the system, and determine if this is really idle. You might be able to save some money. Right? You might be able to avoid the intern problem. Has anybody had the intern problem? No? Nobody's heard of the intern problem? So you're running along, $10,000 a month in Amazon, and you hire an intern for the summer. This is great. You're paid $20K, and they're going to get all kinds of great work done for you. And so the first thing you have to do is what? Give them the keys to the kingdom. Well, here's your Amazon account, and here's the system that's going to deploy our environment. And the intern tries and fails, and he tries and he fails, and he tries and he fails, and finally gets it working. Comes back to the manager and says, hey, I got it working. Manager's like, great, I'm busy right now. Come back in a couple weeks, and I'll talk to you about something else that you can go do, right? Because you figured that out. That's fantastic. You proved that our system works. And then the CFO shows up the next day and says, I just got our Amazon bill, and it's $30,000. Right? So your $20,000 intern just became a $40,000 intern, right? Nobody's had this problem? Wow, you guys are the first crowd that hasn't had this problem. Every other customer I've talked to has said, yes, I've run into that same sort of situation. So part of the idea is just getting visibility into how your system is running. And it's not just simple monitoring, because again, the applications are now these multi-layered things that are not just simply on or off, right? How many containers you're running, are they actually being effective for you? So that's really what we're trying to accomplish with this. And like I said, it's going to be open source. We are trying to make sure that we have some base features within the platform. And I think this is probably invisible to the community online. But really, so a basic dashboard with multiple cluster support. What we're seeing is that a lot of the customers that can make use of this effectively right away are not deploying a single Kubernetes environment, they're deploying multiple. But the same concepts could be applied to somebody that has multiple namespaces within their environment. So that's a fairly easy update to the environment. A busy analyzer, this is the machine learning aspect. Is the system busy or not? Right, so can we enable that? Node assessment, how many nodes are you using? Are they ever effectively used? One of the cool things about Kubernetes, I don't know if you guys, again, most of you haven't really worked with this. Actually, it's not even Kubernetes. Container tools in general have this concept of quality of service for the container. And they also have a concept of resource limits. So you can define network, storage, compute, memory resource limits. So you can say, hey, this container is not allowed to have any more than 1 gigabyte of memory and access 1/10 of a CPU. It may seem like a lot, it may seem like a little, right? But with that information, I can actually go through and say, hey, you're never going to be able to use this XXL node that you've deployed. Because you're not deploying enough containers, and any one of those containers, you need 1,000 containers to get to the entire memory space and the entire CPU utilization of this node. So either change your resource definition or change your node type, right? So being able to get access to that information is really key. There are a couple of Amazon-specific modules. This is something that we're building as a pluggable resource to talk to Amazon to understand node-level billing. So if cost is important, if you are in Amazon, rather than just looking at potentially consumption in a private cloud, we'll be able to talk to Amazon, get that billing data. It should be trivial to do that for Google, IBM, Azure, et cetera, in the same sort of space. You'll notice that there is a pretty heavy Kubernetes focus on this. But that's just because, again, one of the things that I saw was that in the VM space, people have some tools already. They understand what their application is doing. They've hopefully already gotten to the point of right-sizing their VMs for their application environment. Still not 100% true, but it's more true than not. In the Kubernetes space, there's this disconnect because the developers are potentially just using the system rather than understanding what's going into the system, right? And so there's potentially a cost loss or a cost or consumption loss just because of that lack of visibility. Yeah, overview, just to give you an idea, like I said, there's effectively a dashboard view, and the reports are the dashboard. So those would be sent to you on a daily basis if you wanted to see them. Eventually that's alert driven rather than just on a daily basis. Yes?
Can you extract are you guys planning to have some ability to extract data out of this so I can put it in the data warehouse?
Yeah, so right now, the way that the system works is basically we're using the Heapster engine, which is a set of simple tools that get automatically installed into a Kubernetes cluster. Very easy to add to any cluster, and it points to an external influx database. So you have an influx database, you can pull directly from that and store it somewhere else, and this tool wants to use that. Alternatively, if you already are doing something like Heapster to influx, then we can just point to that same influx resource and just use that data. Right? In fact, one of the things that I'm hoping people would be able to do pretty quickly is start to collect some, hopefully somewhat anonymized data. But what we're really getting out of this in general is, the one thing that's not anonymized are your container names, right? But other than that, it's IP addresses. Usually those are already 10 dot network addresses because of the way the Kubernetes system usually gets deployed. Node names, but usually node names are also fairly generic. I mean, even in an Amazon environment, the nodes are named something like node-IP address, and usually that's generic. So I think it's going to be fairly simple to be able to sort of clean the data in such a way that we can actually create a central repository of shared data of how these systems are being used. And that's useful. There are so many people out there that are looking for large data sets to build machine learning models on top of. Right? I think we're going to get community help to start doing that as long as we can actually provide some data back to the system.
Yeah, because I'm interested in it for a different reason, which is to be able to associate this kind of data with business function
Sure.
information. And in fact, in general, that, you know, like a lot of times it's not just, are these clusters, you know, efficiently utilized, or more like, hey, what's my ROI, you know, for a particular department, business function?
Yeah, so I talked about efficiency because initially when I started talking about this to people, I was talking about cost. Oh, we'll help you reduce the cost of your cluster. It may not be a cost reduction. It may just be proving that, hey, look, you've kind of consumed this resource to its limit, and in order for your engineers to continue to scale, you need to give them more capacity, right? Or it's maybe an internal resource where there is no chargeback cost, right? It was a sunk $1 million system deployment, and now it's going to be amortized over 3 years, but you still want to make sure it's being used efficiently, right? So that's why I think about efficiency. So I think this is effectively, to your point, that first tie-in into the business function. That connection between what does the business need and what does engineering need in order to achieve that business need, right? So those two pieces I think fit together really well. So really that's basically what I had. We do have a little website. If you're interested in sort of keeping track of this, you can drop your email on that. I'm not using it for a newsletter or anything else. It's just an announce. So when we do get this thing released, you can sort of keep up with us. That's my Klumon address, but you know, if you want to reach out, happy to talk to you. Cell phone number there too, whatever you'd like. I think there's a lot of value in this class of tool. Obviously, I'm looking at it from the perspective of if I can get this to work, I can get some more consulting. That's a good idea, right? But I also have talked to so many people that have issues in this space. They just don't have a good way of understanding what's going on. So maybe we can just help the community in general with that. All right. So with that, thank you very much. Appreciate your time.
Hey, can you get to start to ask Robert anything, Session? You don't have to ask him about, look, see, you thought you were going to unplay.
That's going to be done.
Alrighty. Can you monitor your own Q&A? I'm busy live tweeting all of this.
Sure. Okay. Well,
I don't need you to stand up here and facilitate. Come on. We've done this before. Okay, we're going to start
Okay.
there.
So first question, yes.
I was wondering if the lack of visibility into operational efficiency is maybe a side effect of agile teams not having formal ops roles anymore. By calling things DevOps and saying we can get a DevOps engineer who can do sort of both, really what happens, he becomes a developer and then the ops doesn't get done. And you have an environment.
Yeah, well, I think what happened was, you know, the developers that started the whole DevOps craze were those that were, you know, suddenly able to spin up virtual machines on their own and create networks on their own and create storage on their own. And yeah, they didn't come at this with an operational compliance rigor. They said, this makes my life easy. And I'm happy to take on the extra challenge of managing an operating system and dealing with SAN storage backup and, you know, having to deal with firewall and load balancer rules in the network because I can, right? And that's a hugely powerful component of things. At the same time, most systems that actually go into large-scale production, there suddenly is this other team that sort of shows up. Right? Yeah, they're the real operators in a sense, and that their job is now to manage compliance for, you know, SEC traded, or, you know, SEC managed companies and things of that nature. So there is some of that goes on. The SRE community, right? So this name that sort of Google termed a while back is effectively that operations-driven application development community. And even then, I think they're still coming at it from what I was sort of considering that old school operations. What are our servers doing? What are our networks doing? What is our storage doing? Are we in compliance? Have we managed our configurations stably? Right? Rather than saying, yes, but on top of that, we've got this layer of massive change. How do we integrate those two pieces together more effectively? Right? And most of the SRE models that I've seen, and there are a lot of them because there's no one answer to that one, unfortunately, most of them are actually more developer focused than operations focused. Right? So I started talking about ops dev right? The inverse of DevOps, it's like, okay, it's still development. I still think that the right answer is to automate the tasks, understand what it is, and automate the problems away effectively. But it is more operations focused, right? How do I make sure I don't run out of storage, right? I might not be able to ask for more. That's this fallacy of the cloud. I've actually talked to a couple of customers recently that said, yeah, I have 5 Amazon accounts because we actually have to spread our load across them. Because there are times when I ask for 150 servers, small ones, but ask for 150 servers, and I only get 100. Right? The other 50 aren't available. I have to go somewhere else into a different environment to get those extra machines. So there are aspects of operations that I think sit outside of what most developers are trying to think about, and really they should be working on the app. Right? That's where the business gets value, is by adding new features, adding new capabilities. Right? So I think there is a delta there. Right?
So do you have a standard way that you're defining an efficiency score? And if you do you have a way to customize it?
Right now we don't. Our efficiency score is just effectively percentage of utilization. It was just a number that goes from 0 to 100 and gives us some kind of idea of what's going on within the cluster. Right? As the system starts to have some machine learning smarts to it, I think it's still going to be a 0 to 100 score, but it will actually be based on actual utilization. Right? So, yeah, it was intended to be just a simple, rule of thumb. Is this good or bad? Is 50 good or 50 bad? Well, it really depends on your own business. And to a certain extent, there is sort of a quantization of resource. If I'm talking about virtual machines, I can't have, Google virtual machine, minimum of 1 CPU. They're all the same size CPU, 3.5 gigabytes of memory, and I think the smallest disk you can get is 1 gig. But I'm not even sure you can really do that. I think it might be more like 100 gig is really the smallest disk. So there's sort of like a quanta of, well, that's the minimum, and then I can scale up from there, but I'm still scaling in those sorts of units. And it's different from vendor to vendor. Right? If you use OpenStack, it's different there. And even then, there's sort of internal bells and whistles that you can tweak with OpenStack to say, what's oversubscription that you want, right? So I don't think there's one easy, absolute in what efficiency is. It's more just a number to allow you to start to get an idea of things, right? Again, initially, this is all manually driven. There is no automation. There is no, there's no machine learning driven value for that. But I wanted to make sure there was at least some data point that you could say, okay, well, I see all these systems that do look like they're in use, and I talk to the developers, and they're happy with what they're getting, and I kind of looked at the capacity of the system, and we're above. I did this we did this manually, but we did this with a system where, the systems were running at basically 60% utilization. Well, I couldn't make it any smaller because the next smaller VM size was 50% of the one. Right, so I would have not had enough capacity given what was actually running on the system at the time. And we didn't have enough data yet to look at the actual container load. This was basically limit-based container load, right? Oh, you've asked for 20 gig of memory, but you're running a tiny test system that's only consuming 1 gig of that actual memory space, right? So I'd love to be able to pare that back so that I could actually make this fit into a smaller node. Right, and then my efficiency number would jump up higher, but still 60% might be adequate. Might be, yeah, you've done what I needed. We're finally at a point where we understand what we're consuming and what that cost is.
What are you using for the machine learning piece?
So we were going to look at a reverse neural net. It's not done. That's sort of the earliest phase of things. And I am not a machine learning expert, much though I wish I were. So we've talked to a couple of folks about what we might actually do, but we don't yet have a complete model there. Right? Mm-hmm. Yes, Al.
Yeah, you defined like your idle time is the traffic just for management of your.
That's what we're trying to get to. Yeah, that idle in this system is really what isn't being used, but is still there. Right? There's still going to be some communications going on, heartbeats and things of that nature that will still occur.
Why do you need a machine learning when you can just build up your infrastructure and then measure it without any applications running, and therefore you know what the baseline is, because that's not going to increase as you.
If you build one application and only one application, that may be true, but I have never seen an engineering team sit idle and say, well, this is the only platform we're going to use. We're never going to change how our database works. We're never going to upgrade it to a different version that's going to change how the system looks. I think that there is a need, and especially when you start talking about the layers of application that sit on top. Because it's not just an operating system anymore, where you could say, well, look, there's base communication going on for the operating system, and where things end up is going to change too. Right? One of the things that happens within the Kubernetes environment is you have a scheduler that gets involved in placing things. And one deployment of a system is not going to necessarily look like another deployment. So I can't always say that, yeah, the third node in the cluster is going to have slightly higher CPU utilization, slightly higher memory utilization, and some storage traffic, because that happens to be where the database ends up. Right? So how can I actually make that kind of a measurement? I could try to average the system. Again, that's already sort of the beginnings of machine learning anyway, right? I'm starting to do some statistics against the data that I've got. So that's why I'm thinking that it's going to be useful. I'm not saying it has to be, but so far, I can't see a clear way to give me a consistent, reasonable answer for should I alert against this or not. Right? Yeah.
So when you talk about metrics management tools, are you talking about things that sit above stuff like Prometheus or?
No, I'm talking about things like Prometheus, like a Sensu-driven environment, right? Some of these environments that you have to sort of build yourself and define yourself. I like the Prometheus model. I like even the Heapster model because they're effectively built in. They discover from the platform, from what Kubernetes is trying to do, what's going on within the system, and they can then report against that, right? Because they'll go and query etcd, well, through the API, but they'll say, what pods are running? What should I be looking for, right? And let me make sure I'm querying all that resource. Yes.
This is a more general question, but it seems like one of the really promising things about Kubernetes is it gives you an environment that where you can run apps on a really wide range of infrastructure. So
yes.
Everything from like under your desk to like bare metal hosts at OVH.
Yep.
To Amazon. And what's your sense of from the people that you're working with? Are they all running toward the cloud, or are they seeing this as, hey, like we think about where's the right environment for us?
Yeah, so
to run it? How are people trying to make that decision?
I'm sort of seeing both. There certainly are. There's some little companies that I'm talking to that are like, yeah, we want to get rid of all servers. We even the things that are not cloud native applications, we just want to run them in the cloud because our 15 machines that we were running to run our ERP processes and everything else, it's just not worth it. It's not worth the overhead of having those machines, having to upgrade them every 3 years, sort of a thing, and deal with the security implications of having them running. And yeah, they're looking at where's the most effective way to run a Kubernetes environment. If you go to a cloud, sort of a heavily managed system, you're going to pay more than if you went to a bare metal service, but now you still have to go back and manage those base OSs. Last time I did any kind of analytics on ROI, it looked like 200 or 300 double XL scale systems was about where you would start to see a trade-off, a question of if you're running those systems all the time, then it might actually make sense to have your own operators, have your own infrastructure. It may not be your own data center, it may be an Equinix or what have you data center, but there is a trade-off. There is a point where it can be more cost-effective to run it yourself.
So in that case, you'd be talking a colo versus Amazon?
Potentially, or even, I've talked to a couple of companies that because of how they've built themselves up over the last 20 years, they have their own data centers. They still want to use Amazon or Google or Azure services for their engineering teams where they have this dynamic scale. Things are ramping up, shutting down all the time. But at the same time, they're looking at their sort of static load from their current customer base or their slowly increasing load from their current customer base, and it's not that dynamic. It's not like, oh, this month I need 10,000 servers, next month I need 100,000, and the month after I need 5,000, right? It's not that super scale that people talk about. And they can usually handle that in the data centers they already have, with the operators that they already have, moving to newer models for infrastructure. One company in particular is in the process, and probably will take them a couple of years, but they're taking all of their old school RPM-based applications, and they package everything with RPM on Linux. They're taking all of that infrastructure, moving it first into containers, and then managing it on top of Kubernetes. And their engineers are going to be using both Amazon and in-house resources for development, test, QA, and then their production is all in-house. And part of that is the data sets that they create, that they manage, they want to keep in-house. They have data protection and management issues, so they don't feel like that they can put that into the cloud. So we're seeing all kinds of systems like that. But I wouldn't say that there's one consistent model for where that transition point is, or
a pretty substantial number of small companies that are writing to cloud are thinking of Kubernetes as a nice abstraction layer on
Yep.
top of any existing public cloud
Yep.
vendor. And they're saying, we're going to write the Kubernetes, and we know we can run on AWS or Azure or
Yep.
anybody else, and not have to worry about it.
Yep.
So as an abstraction layer, and I think it's a pretty strong use case.
Yeah, we're definitely seeing that, that there is a consistent abstraction. There are still some, it's like we can never quite get away from the infrastructure. There's a really nice abstraction for storage called the persistent volume controller. No, persistent volume, PVPVC, claim. God, I knew it. I don't know why I keep screwing that one up. I think about storage controllers and that throws me off. But anyway, so there's the persistent volume claim, but how you describe what that claim is different for every single vendor, right? And the resource models for that claim is different from every single vendor, right? The underlying infrastructure is a little different for every single vendor. So saying, hey, look, I've got a 4-node deployment of Kubernetes in Amazon versus a 4-node in Azure doesn't mean that they're really equivalent. Right? So now I have to start doing performance tests between them. But to your point, they are at least consistent enough that my operations tools can start to deal with those minor differences. Right? Yeah, if I write a claim or if I write a system that's going to go into IBM, I have to think about their gold, silver, bronze model versus Google with their standard and premium model. And so I have to just define those names slightly differently depending on my actual target. But I can do that, and I can manage that. Right? And I think that's the real power. It was something that OpenStack had tried to enable, right? Hey, let's define one sort of model for interfacing with virtual machine-based infrastructure. And they got pretty close, but there really weren't enough consistent OpenStack systems out there to say, oh yeah, well I can go to Amazon and get OpenStack, and I can go to Google and get OpenStack, right? So I think that Kubernetes has somehow managed to trump that by sitting on top, right?
I think it's a classic, the layer's been added, so there's abstraction, but now you still need an ops team that actually takes care of the details of the abstraction.
Yeah, but I would say the one big difference as well is that with Kubernetes, a lot of the core application management operations are already defined as controllers. So like scale up, scale down functions, even some of the stateful interactions are defined as controllers. So there's a stateful set component. And the only thing that I'm seeing, I kind of threw it up on that one slide, is that there is this concept of an operator that the CoreOS community or the CoreOS folks created about 1.5 years, maybe 2 years ago. And that actually I think has taken hold. A lot of people are building operator-based models for certain infrastructure. The classic ones were etcd and Prometheus were the first two that CoreOS provided. And the idea behind those was that the general controllers are very good at turn on, turn off type interactions. Right? Hey, I'd like to deploy a daemon set. What does that mean? I'm going to have a pod on every single physical node of my infrastructure or virtual node of my infrastructure. And I'll let that run. And if I delete a node, I'll delete that particular resource. And if I add a node, I'll add that resource back. Right? Nice controller, sort of handles that kind of general operations process. In etcd, if I lose one of 3 nodes in an etcd cluster, adding that node back is not just turn it on. You have to turn it on, you have to sort of tell the other cluster, oh, we're adding this guy back in, we've given him the right key, he's okay, send him the data, kind of a thing. There is no default controller in Kubernetes to do that. So instead what they did was they said, well, we know that this is a common operation if you're using etcd. So we'll write sort of the control logic around that and add that in as a custom resource. I would like an etcd, please. Right? And so then that is much like a deployment in that it handles, oh, something scaled up, something scaled down, but it wasn't supposed to have scaled down, so how do we scale it back up to where it's supposed to be and handle that, right? So that's the operator component, and it's trying to take some more of that, again, classic operations model and apply it to this really dynamic environment where it's going to be hard to handle, 10,000 systems deployed like this. Right? You're never going to have people that can do that, not enough people to do that, so you need to start automating these tools. Right? Now you have some interesting ways of enabling that automation. So when you say, yeah, you're going to deploy etcd, fine, use this operator because it provides a lot of that operational knowledge for how to actually drive that system. Right? So you don't have to have a really smart guy available just to handle that one piece of the puzzle. Right? People are doing that for most of the databases that are out there. And it tends to be that, oh, I've got some state associated with this, probably going to need an operator to make that really work well within the Kubernetes space. Right? Yep.
There's Kubernetes API data store replacing etcd.
Yeah, etcd, well, that's the common one. Console is another one. I don't know if anybody's done anything beyond those two by default, but any key value store.
Console is old one, right?
No, it's a HashiCorp tool. It's just a different vendor. It's a vendor-driven tool, whereas etcd was kind of, well, quasi-open, although console's kind of open-ish.
So is Kubernetes API data store going to replace those? Or who's winning that? Or
From what I've seen, people still deploy etcd. That's the answer.
well, yeah, that's only because it's working now and it's not still in the development such as Kubernetes API. Data store.
I just haven't seen anybody say that's what we need to go deploy. So maybe it'll change, right? I mean, they changed from the Sky DNS service to Kube DNS and now to Core DNS. So I mean, the things will change under the covers, but they'll be abstracted from the controller, right?
And I promised Robert, I know he's got a plane to catch, and as important as he is, they don't always wait for him when they want to.
They usually don't wait for
San
me.
Jose Airport or San Francisco?
Yeah, San Jose.
Okay, so you don't have that far to go.
No.